No noise. You're welcome to Frank Teaches DevOps series. All right. In this series, I will be showing us some. The series is solely on Dick's partitioning. Dick's partitioning on AWS and on an EC2 instance. Sorry for that. On an EC2 instance, but it's going to be two-sided in such a way that um, I'm going to be I will create a volume on AWS and attach the volume to the EC2 instance and use that volume to create partitions. And the partitions will lead us to logical volumes as well. So the goal for today would be first I create an EC2 instance. Second, I attach this EC2 instance has a volume already, but I'm going to attach additional volume to the instance, to the EC2 instance. Then I'm going to log into the EC2 instance and create more partitions from the attached volume. All right. Yeah. At the end of the day, I'll I will create a physical partition, and I'll also create logical partitions. Logical partitions. So the focus for all of these is for me to have space for my data storage. All right, for my data storage. So let's hop onto AWS and have access to my EC2 instance. So I'll copy that and I will paste my key. Mm. All right. So if you can see Dix free H, I have I have this volume XVDA one. All right, on this machine. So if I even do fix Dix minus L, I only have just one partition XVDA, which is 10 GB. So I want to go back to AWS and create a volume and attach the volume to my EC2 instance. All right. So that I'll be able to manage the volume from inside of my EC2 instance by creating partitions. All right. So what I will do, I'm going to shut down this instance, shut down this instance. My instance is down. So I'm going to hop onto AWS, back to AWS. So my partition demo instance is going down. So I'll move on to volumes and I'm going to create a volume. I'm going to create a volume. I'm going to create a volume of, let's say, 40 GB. Okay. All right. Okay. Then I'll click on what? Create volume. Where's the created volume? What was the time? 40 GB, right? So let me call it part vol. I just created a volume and I need to attach the volume to my running instance. Mind you, you have to shut down the instance, all right? The volume is available to be used. So I'll attach the volume to my EC2 instance. So I'll click on attach volume. I'll search for my EC2 instance. My EC2 instance is partition demo. Then the device name, mind you, um, the first device name that came with our EC2 instance is sorry, our EC2 instance is slash dev slash svda svda. So for me to create another volume, for me to attach another volume to my EC2 instance, the device name will change from A to B. Okay, so go back to here. So say SVDB. All right, SVDB. I'll click on what? Attach volume. So if everything goes fine, I should be able to attach my volume to my EC2 instance. So let's go back and power on the EC2 instance. All right, so I'll go back to EC2 instances. If I go to storage, so far I have the original volume that came with the EC2 instance. So I have to power on the EC2 instance. Start instance, and let's see, refresh. So you can see if I select um, my EC2 instance and go to storage, click on storage, you see that I now have two what? Two devices, two volumes attached to my EC2 instance. The first one being the original instance, original volume, which is 10 GB, and the second is the one I created and attached to it. All right, so that's fine. So now let's gain access. Let's go. Let's now access our EC2 instance. Connect, copy. All right, paste that. Let's see if everything goes fine. We should be in. If everything goes fine, we should be in. Still coming up. Let's go back. Still coming up. Still initializing. Refresh. Refresh. Okay, it takes time to come up. So let me pause the video and I'll be right back. Okay, you're welcome back. So our status check is up. So click on the partition, the EC2 instance, click on connect and click on connection string, which is our SSH connection string. Then we hop in here, paste it. Yes, we should be in. Yes, we are in. Sudo. So now at this juncture, if we should use our Dix utility tool, which is the fdix, and list the number of partitions we have, so the number of volumes we have on our EC2 instance, you see that we have the original volume, which is 10 GB. They'll now have the attached volume, which is 40 GB. So now we now have additional volume we can play around with. Okay, so now let's still use fdix. Let's go into the new volume, 40 GB, to create partitions for our data storage. All right, so slash dev svdb. Okay, so we are inside of this. So if I press P is going to print the partition table. At the moment, we don't have any partitions created on our volume. All right. So let's see how we can create create partitions. All right. And if you can see, I'm on the fdix utility command line 2. So if you press M and hit enter, M will show you all the possible commands you can pass, the possible flags you can pass on your terminal, on your fdix utility terminal. All right. So you have D for delete, you have list free on partition space, you have list partition types, N is to add partitions, P is to print partition table, T is to change partition type, and M is for help, as you know. Then W is for to save and quit, and Q is to quit. All right, so we shall be starting with the first flag, which is P, creating partitions. So the first partition I want to create, N, sorry, P is for print. So the first partition I want to create is a primary partition. Okay, so I want to create a primary partition where I can store my files. So what I will do is I press P, primary partition. So partition number, I'm going to use one. Take one as my partition number, and the first sector, the system is giving me the first sector as 2048. Yes, I'm going to assume the first sector. So out of 40 GB, I want to create a partition size of 10 GB. All right, created. So if I click on P, type P, you see that I have a partition of 10 GB created. So that's all I need to do. So I'll type on W to save and quit. Save and quit. Now, there's a file in our Linux file system that takes inventory of your partitions. Okay, that file is under proc. So if I say cat etc proc partitions, I should see the newly created partition. So the newly created partition is xvdb1, is b1 from our 40 GB we created. All right. So but if I do disk free, I won't say it because so far it's not part of the file system because it's still a raw partition. It's a raw partition, and there's no file system has been written into the raw partition. So I have created a 10 GB partition. So the next thing I will do now, the next point of action is to format the partition. So I will write a file system into it. By formatting it, I am writing a file system into that partition. So what I will do, I will take another utility called mkfs dot. All right, we have different file system types. We have FAT, we have ext4, ext3, 2, and CRAMFS. We also have Minix and MS-DOS. We also have VFAT and XFS. But in this series, I will be creating, I will be formatting the partition based on ext4. All right, so I'll say mkfs.ext4, then I would specify the partition name slash dev slash svd b1. Okay, the moment I hit enter, I'll be able to see that my partition has been formatted. Partition has been formatted. So at this juncture, my partition is ready to be used. So the next thing I will do now is I'll I'll try mounting the partition. All right. So by mounting, it means making the partition available to be used. So if I check my environment, if I click type on mount, mount will show me all the partitions I have in my environment that are mounted, all the mounted partitions I have. All right. So you see our first volume. So our first partition from our first volume is mounted on the root file system. All right. Yes. So I want to mount. the 10 GB partition we just created. So what I will do, I will make a directory. Let me make it that. Let me call it my data. Let me call it data files. Data files. All right. So now I want to mount the slash dev slash xvdb one on slash data. So what I'll do, I'll say mount slash dev xvdb1 on slash data. The moment that is done, if I check the if I check the directory of slash data files, you will see lost plus found. Lost plus found is an indication telling you that that partition is already mounted. Okay. So now at this point, if I now do disk free minus h, I would see my xvdb1 mounted on what slash data files. So at this point, I will be able to now start saving files. My picture could be my picture files, could be my video files, it could be files with larger sizes, all right, on my created partition. All right. So there will be no need for us putting pressure on our root file system. Okay. By so doing, we've been able to leverage some of the load, all right, the storage space on the root file system into an ordinary partition we just created. Okay. Now I can create some files in that partition. So let me say touch file one, file two. I can make directory mkdir slash data files, my stuff. So I can check the directory of I can do a directory listing of where my file is located. All right, my partition is mounted, but so far these files are not persistent, and the mount point as well is not persistent. Persistent meaning that if this system goes down, I'm going to lose every content in slash data files. All right, I'm going to lose everything. It's not persistent. So the mount I have made is a temporal mount. Okay, but let's check if actually what we are saying is the fact. I'm going to reboot this machine, and once it's reboot, I'll come back and I'll boot it up again. I'll come back and check the directory where the partition was mounted and see if we still have those files in there. All right, I have file one and file two under slash data files. So I'm going to reboot this machine. I'll reboot this machine and see if when I come back, I will be able to see those files there. So let's reboot. My machine is being rebooted. It's rebooting. All right, so let's go back to AWS portal. I'll refresh. It's rebooting. Let's see if the volume will be the content of the partition, sorry, will be persistent. All right, I think it should be fine now. So let's go back. Click here, connect, copy. Let's see. All right, it's down. Let's come back. Let me see. All right, sudo su. Let's check. Let's check our files. If we still have the files under slash data files. So you can see I've lost everything. I have lost the entire content of my files which were mounted on slash data files. I've lost the entire content. Now there's a way we can make all of these persistent. It will be permanent. All right. To avoid these non-persistent flow. All right, non-persistent behavior. There is a way we can permanently make our files available. So that is by making an entry in slash etc fstar. So there's a file called slash etc fstar. So I'm going to make an entry in this file. So before I make an entry, I may have to mount mount it back. So let's do that quickly. So if I do also do disk free minus h, you would see that I can't find my mounted partition. So this is what I will do. I will mount it back slash dev slash xvd b1 on slash data files. Is there. So if I do df minus h, I'll see that this guy has been remounted. However, it is not permanent. So I want to make it what? Permanent. So I'm going to make a an entry in etc what? fx tab. So I'm going to look at the format of the fs tab file. So the format is the first is the UUID. UUID is a universal unique identifier. So this identifier, this value is used to identify a block device. Every block device, all right. Every block device is identified by a UUID. Then the next part is the mount point. Where is the partition being mounted? And then the next column is the file system type. So the file system type they've used here is XFS, which is extended file system. All right. Then these are these boot checks, all right, and sector checks. Okay. All right. So let me go out of this file. Then I'll go and generate. I'll go and check the UUID of my partition. So I'll say there's a command we use in checking in displaying the UUID of a block device. All right. So the command is blkid. So blkid, then I'll specify the the device name. Device name is xvdb1. So once I hit enter, I'll see that automatically it will pull out the what? To pull out the UID of that device for me. Ordinarily, if I say this, okay, okay, it will show us, but it will display all the block devices we have on our system. So I just want for SDB1. So this is what I get. So I'm going to copy this, copy it, copy. Then I'll open my FS tab. I'm going to paste it and make some changes. Remove the excess. Remove the excess. Then the next column is the mount point. So this partition is mounted on slash data hyphen files. The next column is the file, the file type, the file system type. The file system type is ext4. So my next column will be for this file for the partition checks. So I'll say default space 00. I don't want any checks on that partition. That's why I put it as 00. So once all of that is done, I will escape and save and quit. Save and quit. So at this juncture, um, I need to hop into, I need to check the content of, can you see? Can you see? Without creating anything, I didn't create, I only created these files. I only created those files before I, before mounting it permanently. All right. before mounting permanently, meaning that those files were still there, but they disappeared somehow. All right, but they were somewhere in still in the partition. Files never lost in partitions. Okay, but since for the fact that I have made it persistent, those files are now back. Okay, so if I reboot this machine and boot it up, you see that I'll still have those contents. So let's check. I'm going to reboot this machine forcefully. Reboot the machine. It's rebooting. Let's pause the video and we'll be back when the system finish booting. All right, thank you for your patience. You're all welcome back. So, all right, let's log in back to our EC2 instance that we just rebooted. Okay, sudo. Now, let's check if the partition is persistent. So, I'll say disk free, which is a df minus h. So, you will see with me that I still have my partition xvdb1 still mounted on my what directory directory. So if I do ll data files, I will see that those files are still there. So far so good. We've been able to see how we can we created an additional volume on AWS, and we attached the volume. Let's see the breakdown, what we just achieved. So this is what we just achieved. One, we created um, an additional volume of 40 GB. All right. Now we attached the 40 GB volume to our running EC2 instance. Okay. Then we went into the EC2 instance and we went into EC2 and created partition partition of 10 GB from the 40 GB volume. All right. Then four, after that, we mounted we mounted the partition and start saving files in it. So that's what we've done. We've been able to achieve in this short series. Okay, and the part two of the series, sorry, part two of the series will come immediately. Immediately, part two of the series comes in immediately. So the part two of this series, I'm going to create um, create partitions from I'm going to create a logical volume. All right. So the process of creating a logical volume, this is part one of the series. Then part two, all of these is my goal. The goal of all of these is to save your extra files with large sizes. All right, extra files. So you don't put pressure. You don't put storage pressure on the root file system. Okay. So my second part. So this is the second part of this series. So in this second part, I'm going to create physical partitions. Partitions. All right. From the physical partitions, I'm going to create physical volumes. We'll create physical volumes. Create physical. Sorry, physical volumes. Then from physical volumes, we are going to create volume groups. Then from the volume group, we will now create logical volumes. Logical volumes. Then after creating logical volumes, we may now format those logical volumes and mount the logical volumes and start using, okay, create logical volumes and, format the logical volumes and mount the logical volumes for usage, right? So in the second series, the second part, we're going to create physical volumes, physical partitions. From the physical partitions, we are going to create physical volumes. From the physical volumes, we are going to create volume group. From the volume group, we are going to create logical volumes. And from the logical volumes, we are going to format those logical volumes. After formatting the logical volumes, we are going to mount those logical volumes for them to be used as for storage, for them to be used for storage. Okay, so let's hop back to EC2 terminal. So far, slash dev SDB. So everything is coming from SDB. So if I print, I just have this only this physical partition. So I want to create more partitions. So I'll click on N, type on N. So the kind of partition I'm going to create is an extended partition. So from extended partition, I can start creating other physical partitions. All right. So I'll click on type on E. So my partition number is 2. That's fine. The first sector is giving me a default. That's okay. Then the partition size, I'm going to create, let me create 20 GB. 20 GB. Mind you, I still have 20 plus 10, 30. I still have 10 GB free. So print, I now have DB2, okay, of 20 GB. So from this 20 GB extended partition, I can start creating other physical partitions. So I'll click on N. So what am I creating? I'm creating a logical partition. So logical partition L. So the first sector, that is okay. Second sector, I'll say plus, let me take 10 GB. Let me take, that's okay. Let me take 10 GB. That's fine. Okay. New, logical. First sector is okay. The next one, I'll take 5 GB plus 5. We just created 15 GB. So I'll be left with some minor. It will not be up to 20 GB anymore. All right, because if I try to create additional 5 GB, first sector is that plus 5. I'm going to get an error that the value left is out of range. So I'm going to reduce it to, let's say, 4 GB plus 4 GB. All right, good. So I'll click on type P to print my partition table. So from my partition table, I have DB5, DB6, and DB7. Okay, now look at the ID number and the partition type. The partition type is a regular Linux partition, all right? But my focus here is to use this partition to create a logical volume. So for that reason, I may have to change the partition type ID, all right, so that it will reflect Linux LVM, which is Linux Logical Volume Manager, because the goal is to create a logical volume from these partitions. So the next thing I'll do, I'll type T. T is to change the partition type. Change the partition type, and I want to change from 5, 6, and 7. Let's start with 5. Enter. I don't know the code. I'm not aware of the code of Linux LVM. So I will search for that code. So I'll type L, capital L, to search for the code. So I will see, okay, it's 8E, Linux LVM. So this is the partition type I may need to change all my partitions into. All right. So that's it. So I'm going to press a Q. Q will take me out from here, or an enter. Let's see. Okay, Q. Q is going to take me out from here. Then let's go back again. 8E. Don't forget. C 5. What's the code? The code is 8E. 8E has been changed. Can you see now? Change type of partition towards Linux LVM. So I'll go to my T again. The next partition number is 6. I'll say 8E. That is done. All right. I'll do the next one. T 7. I'll say 8E. Great. So if I press P to print the partition table, I will see that my partitions type have changed from Linux towards Linux LVM. So at this point, I can now write the partitions I've created to the partitions what table permanently. I can permanently write these partitions to the partition what table. So by that, I will press W on my keyboard and press enter. So that's it. So, like I said earlier, there is a file that makes an inventory of all the partitions in your Linux file system. So that file is under proc partitions. Let's see. So far, we don't have these partitions 5, 6, and 7. We don't have them. All right, because they have not been the partition table has not been updated. The partition table has not been updated. So the only way we can update the partition table is by running a command called partprobe. We're going to run this command called partprobe. So this partprobe is going to reread. It's going to what? Read the what? Partition table. So what I'll do, I'll say partprobe slash dev svdb. So when that is run, if I check my partitions table again, you'll realize that I now have 5, 6, and 7 listed in my what partition table. Okay? Okay. So now we have created these physical partitions. Physical partitions. Task one has been achieved. So move on to task two, which is what create physical volumes. So I'll go back to my terminal. So to create these physical volumes, I'll do pv create slash dev xvdb. Sorry, xvdb was 5 created, 6 created, then 7 created. So now, how do we check the information about our physical volume? So we say physical volume display. So it's going to show us all the physical volumes we have on our machine. So we have this with their sizes. SDB5 is 10 GB. SDB6 is 5 GB. Then XDB7 is 4 GB. Okay. Immediately that is done, we move on to the third task. Our third task is create volume groups. So from the physical volumes, we are going to create what? From the physical volumes, we are going to create volume group. So what I'll do, I'll say volume group create, and I'll now specify all of the um, the physical volume names. So the volume group name I'm going to create will be, let me just give it a name, my vol. All right, my vol is my volume group name. Space, where am I creating it from? Slash dev xvdb5. All right, slash dev xvdb6 slash dev xvdb7 xvdb7. All right, so if I hit enter, it will tell me that volume group my vol successfully what created. So if I want to check the size of the volume group, I will say volume group display. That's the information about the volume group. I will see that my volume group is of size 18 GB, approximately 19. That's it. Okay, and the name is my vol. So at this juncture, we will be able to now create our logical volume. So let's check at the next task. So the next task is create logical volumes. All right. So I'm going to just create one logical volume and make use of the logical volume. So out of 10 GB, out of almost 19 GB, let's say 18 GB of my volume group, I want to create a 10 GB of a logical volume from that volume group. So I'll say logical volume create. To create, I will specify the size. I need a 10 GB, a 10G, okay, and the name should be, let's say, data LV, data LV, data LV, okay, data LV 01, okay, from what volume group? My volume group. So if I hit enter, it will tell me that logical volume of data Ds is created. So let's see the information about the logical volume. So if I say LV display, I'll see that a logical volume on this path has been created with a size of what? 10 GB. All right. So now we are all done. We are done. So the next thing we need to do now is to create a file system on the logical volume. So by creating the file system on the logical volume, we are going to format the logical volume to an extended file system. So what I will do, I will say mkfs ext4 slash dev slash my vol and then my logical volume name. All right. So once I hit enter, it will tell me that yes, a file system have been created on this guy. All right, it has been created. Okay, but it has not been mounted. So we need to mount it so that we will be able to use that partition, that logical volume as for our data storage. For our data storage. The next thing I will do, I will say mount. Let me create a directory, mkdir. Let me call that company files. Company files. All right. Company files. So I'm going to mount my mapper, my vol, this. Okay. So I'm mounting my logical volume on company files. Oh, I have created the company files somewhere else. It's not on the okay, that's all right. Company files. So I'm mounting this on company files. So if I do check the content of company files, I should be able to see a lost plus found. Now if I now do df minus h, I will be able to see that my logical volume is mounted on slash root slash company files. I don't like it the way it is. I don't like the way it is where the company files is. So what I will do, I'm going to unmount company files. Is unmounted. So I will remove that directory and create it somewhere else. Create it somewhere else. All right. Create it somewhere else. So what I will do, mkdir, create it under company files. The root file system. That's okay. So I'll now remount it. I'll say mount slash dev mapper, my logical volume on company files. All right. So that's fine now. So if I do df minus h, I should get something. Okay, very nice. It's nice. It's nice. Okay. So at this juncture, I want to make it persistent. I want to make it permanent. So by making it permanent, I have to create an entry in what slash etc slash fstab. So what I would before I do that, I have to generate the block ID. The block ID of slash dev mapper, my vol, will be this. So I'll copy this, copy, 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 copy. I'll go to my etc fs tab and I'll paste it there. Paste, remove this, remove this. So where is it mounted? It's mounted on slash company files. So the file system is ext4. File system checks defaults 0 0. Escape, save and what and quit. So far, we have been able to fulfill the fifth task, formatting the logical volumes, as well as the sixth task, mounting the logical volume for usage. At this juncture, you should be able to use both volumes, all right, separately for your data storage. And the goal is just for you to have an extra partition for storing of data. Storing of what? Data, miscellaneous data. It could be packages, it could be files, it could be pictures, it could be videos, it could be anything. All right. So disk free minus H, that is it. So going forward, all of these will be persistent in our file system. So thank you so much. Thank you everyone for the patience, and then see you again in our next series. Thank you.